In Precalculus, section 1.1, we're dealing with functions. Now please remember, since this is your very first video, that you have to do vocabulary. So go into the book, get the highlighted, and put that in your notes before doing the video notes. So do that now, pause it if you need to. The first section we're going over is functions and what is a function and was not a function. So basically, if I have an equation, y equals 2x plus 3, and I put a number in like 2, right? I will get an answer. If I put a 2 in again, I should get that same exact answer. If I put in 2 and I get a different answer, then it doesn't make sense, so there's no longer a function. For example, when we're dealing with points here, -8, -5, these are all called one-to-one. That means for every one x, there's one value of y. Now, I can have a number that I put in here, and it gives me an answer, and then put another number in, and it gives me that same answer. So I can have a repeat in y. I can't have different y's for the same x's. That's the underlining meaning. So if I can have, let's say 0 here, I can make this also -5, and this would still be a function. Now the problem is when I get here, where I do -8, -5, -5, -4, and then I have a -8 again, but this time I have a -3 instead of -5, this makes it not a function. The fact that I have the same x, different y's. All right? Now with a graph, it's a very similar thing when we're doing this, when we're doing the function. But it's hard to just pinpoint every single point. So what we do is we call the vertical line test. So we put a vertical line on here, and no matter where we put the vertical line, it will only touch this vertical line once. That's what makes it a function. That means for every x I put in, I get a specific y. Now, for this example, when I do a vertical line test, it hits the line twice. So that means for this x, wherever this x is, okay, it gives me a y value here and a y value here. That means if I plug in the same x to an equation, I get a y, and I do it again, and I get a different y. So this then is not a function. And that's how I can tell. The vertical line test helps me figure out not a function for graphs, and then to figure out the relation between numbers for when they list out the points, the x and y. Now, function notation is something that you probably saw in Algebra 2, and hopefully that you'll remember. When we have an equation, y equals mx plus b, hopefully you remember that as the equation of a line. But when we replace f, we can also replace f of x with y because they're interchangeable. This f of x is the same thing as saying y, but it's called function notation. This means that if I want to replace the x with any of this, I can put it in here without using too many words. So function notation comes in handy, and you'll see it in your problems. So anytime you see f of x, your brain should automatically think y. So go ahead and pause this and write it down, and we have other boards. All right, so the first one here, you don't need to write this down. So the first one here is saying, if f of x equals this equation, find each. So basically, whatever is on the inside here, I'm going to replace it with the x's for the equation. So I say this f of 3, okay, f of x, f of 3. So everything that I have here, I replace with the inside of x. So this becomes 3 squared minus 2 times 3 minus 8. So order of operations, I do powers in parentheses and multiplication first. So 9 minus 6 minus 8. And then order of operations, I do left and right addition and subtraction. So 9 minus 6 is 3. Minus 8 gives me -5. So the value of f of 3 is -5. Next, I'm replacing all of x with this whole equation. So it looks like this. It's going to be -3d. So wherever I see the x here, I'm going to replace it. Minus 2 times -3d minus 8. So because there's no plus or minus in here, because if this was a -3 plus d, squared, I would have to do this. there's not, I can just take this and distribute it to each one. So this would be -3 times -3, which would be +9, and then d squared, right? And then I'd multiply these together, which gives me +6, so +6d. And then I'm going to bring down -8. Now from here, I would combine like terms, but d squared is not a like term with d, and it's not a like term with -8. So because I can't do anything else, this then becomes my answer. So the last one is a little bit tricky, and it's not tricky, just long, because we do have one similar to this, right, where we have to, or we have to do 2 bubbles and then distribute it out. So this becomes 2a minus 1 squared minus 2 times 2a minus 1 minus 8. So before I do anything, I'm going to first take care of this, and I'm going to do it here. And this is 2a minus 1 times 2a minus 1. So this, you use the method of foiling, but for those of you who took Algebra 2 from me last year, I don't really like foiling because it only works with 2 terms, and if you do 3 terms, it'll throw you off. So it's just a method of distribution. So we're going to take every term here and multiply by every term there. So it's 2a times this whole thing, 2a minus 1, and then minus 1 times this whole thing, which is 2a minus 1. Then I distribute and then combine like terms. So this becomes 2a squared, 4a squared, and this becomes minus 2a. Now I bring the whole sign here. This is negative 2a, and this whole thing, this negative 1 times negative 1 is plus 1. So this is 4a squared. This together makes a minus 4a plus 1. So now I'm going to take this whole thing and replace it in for this. So my next step is 4a squared minus 4a plus 1, and then I'm going to bring everything else down. Minus 2 times 2a minus 1 minus 8. All right? So again, what I did here is I took this and worked it out on its own, expanded it, and distributed it, and gotten this. So now this is an equal substitution for this. It means the same thing, just written differently. And now I don't have that square to worry about. I can work everything else out. And before I move on to anything, the order of operations says that I have to do this first. So I'm going to bring all of this down. 4a squared minus 4a plus 1. And then I'm going to distribute. Negative 2 times 2a is negative 4a. Negative 2 times negative 1 is plus 2 minus 8. Once I've expanded everything, I just combine like terms and solve. I mean, not solve, just combine like terms. So 4a squared comes down to 4a squared because there's no other squared. Negative 4a minus 4a is minus 8a. And then 1 plus 2 is 3, minus 8 is negative 5. So this then is my final answer. And that's f of 2a minus 1. So go ahead and pause and write this down. There is one more board. I know this is a lot longer than most videos, but we need to take care of it. So pause and write this down. Our last one deals with piecewise defined functions, and basically it's using 2 or more equations for different intervals or x. So where you are in the graph, hopefully this is on, yeah, you can see it. So where you are in this graph, so if your x is here, this is one equation. If your x is here, this is another equation. If your x is here, so it's having different equations depending on which x you have. So for example, between 63 and 66 on your x's, this is the equation that applies. 66 and 68, this is the equation, and then anything that's greater than 68, this is the equation. So the thing to keep in mind is just to figure out which equation you're working with. You're not going to be working, unless you're graphing, you're not working with all three equations at once. You have to figure out where you are in the x. So it wants us to find h of 67. 67 falls into this category right here. So I'm going to be using this one, 3x minus 132. And I just plug it in. 3 times 67 minus 132. And because Miss P cannot do math in her head, we're going to do 3 times 67. 201 minus 132 equals 69. Right? So this is actually easier than the others. It's just understanding how to read it. It might confuse you with these three, but you're not using these three all at once. You're figuring out which one of the three you're using. So this one is 72. 72 belongs greater than this, so we're bringing this equation, we're using this equation for this one. So for h of 72, it's 2x minus 66. So it's going to be 2 times 72 minus 66. 72 is 144. Minus 66, which is 78. Now, this is in fact a word problem, so let's figure out what they're saying. These equations deal with the average max height of children in inches as a function of their parents' max height. So this right here, the x's represent their parents' maximum height, whereas this is the equation to find or estimate how tall their child will be. So with a parent's maximum height of 67 inches, then that means a child will be an average of 69 inches. And for parents with a maximum height of 72, their children will be 78. These equations come because different ages produce different growth patterns. So that's why it depends on which height range, and then which pattern we're paying attention to, and that's why piecewise functions come into play. So go ahead and pause, write this down, and try the guided practice. So it's right under each example problem. So find the words guided practice number 4B and 6C. 4B and 6C. I will see you in class.